Hi everyone, welcome back to Faraday Academy, and we are live with another Python live stream. This time we are working through a challenge called Conway's Game of Life. So I'm going to post the specific CODEWARS.com kata coding challenge that we're working through. Post it in the chat. There you go. So if you want to follow along with us. So if you're new to CODEWARS, then it's basically a website that you go to and you can go through different levels of coding challenges. There are 8 levels. On this channel, I think we've done, it starts with the easiest at level 8. So I think we've done level 8, level 7, level 6, and level 5 now. So we thought we'd tackle one of the harder ones. I think they start to get pretty hard at level 4. So we're trying a level 4 today, and we'll see how we fare solving this. If you have any input, if you think we're doing something wrong or we need to change something, then feel free to comment in the chat. Yeah, just throw any ideas out there that you have. All right, let me switch to the screen. All right, that's just me. I lost. Oh, that's just you. 1 second. There we go. I mislabeled one of my screens again. I have to fix that. All right. So now you can see the kata. Let me actually zoom in here a little bit. Yeah. So I'm just going to read the instructions real quick. And if you're following along at that link, you can read them as well. It says, given a 2D array and a number of generators, compute. Oh, I'm sorry. Wait, I forgot to introduce JT in all this. He's been on so many times now. I just figured everyone knows who he is. JT, do you want to introduce yourself real quick?
Yeah, hey, so obviously my name's JT. I am a graduate of Kenzie Academy, which is like basically a coding school. And I enjoy doing code wars and solving these problems and thinking about interesting problems and stuff. So, yeah, that's me.
All right, awesome. Oh, and I also forgot to say hi to Unknown Man who posted in the chat.
Who's here at 2 a.m. his time?
Yeah. So, all right. All right, the direction. So let me continue. Given a 2D array and a number of generations, compute n time steps of Conway's Game of Life. Now, if you don't know what Conway's Game of Life is, there are lots of examples online because it's kind of a really popular coding challenge. So I'm gonna pull one up here real quick. This should load. So it's basically, these squares are life, and they generate and disappear over time according to certain rules. Is that the best way to describe it, JT?
Yeah, that's a good. And the actual rules we have are in or the rules for whether they live or die are in the kata description. But yeah, yep.
Yeah, okay. So you can check that out on your own. There's also a link to Wikipedia here. So anyway, I'm going to continue. Given a 2D array and a number of generations, compute n timestamps of Conway's Game of Life. The rules of the game are: any live cell with fewer than 2 live neighbors dies, as if caused by underpopulation. Any live cell with more than 3 living neighbors dies. Oh, yeah, more than 3 live neighbors dies, as if by overcrowding. So you want 2 or 3 neighbors, I guess. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any dead cell with exactly 3 live neighbors becomes a live cell. So that's how cells are born, I guess. Each cell's neighbors is the each cell's neighbors is the 8 cells immediately around it. Okay, the universe is infinite in both the x and y dimensions, and all cells are initially dead except those ones specified in the arguments. the return value should be a 2D array cropped around all of the living cells. If there are no living cells, then return an empty array. For illustration purposes, 0 and 1 will be represented as this grayed, or this black box and a gray box or something, blocks respectively. You can take advantage of the HTMLIze function to get a text representation of the universe. Okay, print HTMLIze cells. So it's giving us a helper function, I guess?
Yeah, so basically what that'll do is take the array of ones and zeros that we're going to like return and print out. For every one, you're going to see that white block, and then for every zero, you'll see the like dotted black box.
Okay.
And that's what that function does.
Hi, Derek. How are you? Okay. Conley's Game of Life. I was just checking up here. So a lot of people like this, so it should be an interesting challenge. I'm going to go ahead and hit train.
Okay.
Hi, Abel Hamid. How are you? All right. So this is giving us the same instructions I gave before. We have this get generation cells. Oh, I see. So it's telling us the generations. So we need to write a function for each generation and then loop through or call that function the number of times for how many generations. Okay, so
sorry, go ahead.
No, go ahead.
All right, I would say, so the interesting part of this isn't even going to be the actual deciding if a cell lives or dies, right? It's going to be the actual expansion and then cropping of the area that the cell lives in, I think, is going to be the hard part. Because this can get a little, like, again, into the weeds a little bit, but with you can basically pretty easily tell or build like a hash table or something that you basically input as the key the state of all the neighbor cells plus its cell, and then that'll output whether the cell lives or dies, right? So checking whether each cell lives or dies isn't going to be too hard. We just have to figure out like how to easily expand and contract the actual array that we're going to be working within, which is in this case the universal array. Cool. So we do have the.
I always have trouble working with 2D lists in Python outside of using NumPy. But I guess we'll give it a go here.
Oh, fair enough. I haven't used NumPy. All I have with experience with this is the 2D arrays.
Okay. Oh, right. So we did copy this challenge over to, what is this called? Oh yeah, VS Code Live Share. So that way James and I can both type in here and do the challenge together instead of me just typing into this online interface.
Yeah, and as you can see, I definitely stole that HTMLIze function just so that we have it to play around with, and maybe it'll be helpful. I don't know. So.
This is nice. Yeah. Cool.
Yeah.
And then we also have some tests locally to run. So if it passes our local test, then we'll put it back into the online interface.
Yep, and so typically how I write these out is we should be able to copy and paste the whole file and just put it in the code interface. We could probably still do that, but really want to copy and paste everything into the interface except for the HTMLIze function, or however you would say that. It's such a weird word.
Yeah. All right, so we should start going through the 4 rules, right? One at a time, or how do you want to handle this?
So this one, you definitely could. ideally what you want to do is just go through the array one like subarray at a time, right? So one row of the 2D array at a time, and then just for each cell that is on, or actually for every cell, check what its next generation's like state will be, right? We could do that pretty easy in just a for loop with like 4 if conditions or whatever. What we could also do, and this will be interesting, is we could create a function that will just take a 3x3 say grid, and then return whether or not the center element is going to turn on or off, right? Because you're looking at all the neighbors plus itself to determine what the next state is. Does that make sense?
Yeah, but then for okay, yeah, I think we can start with that. So,
and if we
hi,
reach
nobodies.
if
Good to see you.
hey, what's up? How does a cell know about another cell? Okay, so it's just going to be a 2D cell. So let's actually, if you look in the test, Glenn, we should be able to show the like import or input state of the board. But basically, what's going to happen is it's just a 2D array, Derek. And it has ones or zeros, and so ones are where the cells are on, and then zeros are where the cells are off. And so you just have to check the array to see if it's on or off.
Yeah.
If we, yeah, the other thing, yeah, and let me know if like as I'm speaking or as we're speaking, or whatever, if something doesn't make sense, we'll try to clarify it. If you are on the edge of the array, and for whatever direction you want to check the neighbor, so see if you're in the first position of one of the arrays and you want to check the left neighbor, we can just see that it's out of bounds and make that neighbor effectively off, right? We can just pretend it's off because it doesn't exist.
Okay.
So typically when you do something like this, you probably want to use a dictionary in Python so that we could pretty easily just create a key to value, like put in the state that we want to check, and then get whether it lives or dies in the next generation. The cool thing about this though is we can treat each state as a number, and then check the bits to see in that state if it's on, right? So since we're here in this, you can think of a board that looks like this. Right, this is how you do multi-line comments in Python. So like if you had a board that looks something, one second here, sorry.
Oh, nice. They're just talking about things that they're building in the chat.
Oh, did you? Okay, Derek, send me that, because I've been meaning to do something like that too. As I've been filling out the spreadsheet, I'm like, look, there's got to be an easier way to do this.
So both of you are looking for jobs right now.
Yeah, I've gotten one interview. They haven't gotten back to me, but the HR person that I talked to said that next step would be talking to like the engineering lead of the company. It's a pretty small company, so hopefully that'll go well. We'll see. And then I've got another interview that I'm just waiting for them to get back to me on. I gave them my list of times available, so we'll see how that happens. Out of like 50 applications, I've gotten 2 interviews and so far like 7 or 8 rejections, so that's always fun.
It's okay.
Yeah, I'm not too worried about it. Like, yeah, I'll get something hopefully here soon. So as far as this goes, if you look at this, you can kind of look at this as instead of a 3x3 array, each of these are essentially a bit in a 9-bit long integer, if that makes sense. And so yeah, so we can just, as long as we're consistent with how we form the 9 bits, we can treat this as we can turn this basically 3 by 3 array into a 9-bit number and then pass it to a dictionary after we build the dictionary and get whether this center cell should turn on or turn off in the next generation, if that makes sense.
Okay.
And we'll still have to.
Yeah, I'm still trying to envision this, but go ahead and start typing.
Fair enough.
Oh, right,
so
right. Okay, so you're gonna turn this.
So, like, for instance,
9 bits. I think that's. Yeah, that's better than doing. Manipulating it in a nested list.
Right, because then we can just go cell by cell and then grab its neighbors, convert it to a binary number like this, and then just throw it in the dictionary as the key and grab the next state as the value, right?
Yeah, so we're going to write a function that takes the binary number and checks it, or is the function going to convert it to binary? We pass in the 2D list and...
You can do it either way. So while you're traversing the universe, we can build that way, or we could just grab the 3 by 3 section that we're looking at. I think it's probably better to convert it while we're traversing the list into the integer, because if we try to do 3 by 3, yeah, I think it's better just to convert it first. Because it might be a little harder to grab the 3 by 3 array at the top left of the array, if that makes sense, versus just building the integer and checking to see if anything's there or not.
Okay. Yes, it is the game of life. The link is posted further up in the chat. All right, so what if we made a list of, like, as soon as we get the cells in, because this is cells is a 2-dimensional list that's passed in.
Mm-hmm.
And what if we turn that into a 1-dimensional list of these bits? Like, do bits for each nested list and basically flatten the array.
I could see a couple problems with that. One is we're going to have to, at least on the last test, the universe is actually going to expand from the input. And I think we're actually going to have to, on most of these, we're going to have to do some expansion anyway, and then we're going to have to, like, crop things out of it. But if we convert the input to just a basically string of integers or bits or whatever, we're going to have problems expanding the universe. Whereas right now, all we would have to do to say add another column and row is go through and push an element to the end of each of these array and then add another element that's the same length, if that makes sense.
Okay. That sounds good.
Okay, so then, yeah, the first thing we want to do is build, like, we can do this a couple ones. One way is we can just check every time we send in an integer and count the bits, because the only thing that matters about this number is how many bits are active, right? And I think there's probably a pretty easy way to... Yeah, so...
Jared. Jared says it's very deep of you to expand the universe. Or to think about expanding the universe. Alright. So go ahead and... Oh, you're on top of it.
Yeah. I'm trying... So this is the hardest part for me, is trying to figure out what to name it. It's a hash map of states to whether the thing's alive or dead. You like my shirt, Jared? I mean,
okay.
I don't know if that's a great name, but that's what I'm going with right now. Feel free to change it if you have a better idea.
Okay.
And then, so we're gonna have. There's going to be 512 different possibilities, right? 2 to the 9th, because we have 9. Yeah. So we're literally just going to look through every single number. Yeah, we need access to the number. So all right, I can type correctly sometimes, I promise. So then for each of the number, we need to count the bits that are active that aren't the center one.
Okay.
So what's the best way?
So can we do .count on a byte string?
Oh yeah, I guess if we convert it to a byte string, well, yeah.
Yeah.
So what we would want to do.
Right.
What's up?
I'm talking to myself. Sorry.
You're fine. Okay, so if we convert it to a byte string, what we'd have to do is kind of split it and then count. So we'd have to check the first 4 bits and then the last 4 bits, right? Because we want to ignore the middle bit.
Okay. And then, yeah, because either way, we'll just replace the middle bit with whatever the conclusion of our calculation is.
Right.
But why do we need... Then why do we need to loop through 512?
Okay, so
if we're just
there
counting.
are... Right. So the reason we have to go through 512 is because we're always going to be looking at 9 bits of information, right? Because it's going to be a 3x3 array. And so there are going to be 2 to the power of 9 possible different states that this could be in, right?
Yeah.
And so that's why you have to... 2 to the power of 9 is 512, which is where I got that number from.
But why do we have to loop through every different state if we're... So let's say we're taking these bits, we're counting the number on each side of the middle number. And then
I see what you're saying. So what I was going to do is just build basically a hash map so that we don't actually have to, like, once we're traversing through the array, we don't ever have to actually calculate whether the cell's going to live or die again. We just grab the number, right, and then we put it to the hash map and get the value, or to get whether the cell is alive or dead. But we can just calculate it in a function instead of building a hash map too. I don't know what their space requirements are on CODEWARS, so that could be an issue.
Okay, we'll just keep doing what you're doing then. And also, this is totally in the future, but we could memoize these bits. So eventually, if we pass in the same thing as before, we know what to return. Right?
Yeah. So calculate it and then... Well, right. That's why I was building the hash map instead of just calculating it whenever we grab it. Yeah.
Right. Okay. Yeah. You're right about everything. Okay, keep going.
Okay. So actually, we're gonna need a dictionary to throw this in, and it's I guess let's just call it that. So then basically what we're going to do is we're going to count the first four and the last four bits, and then see how many there are. So what we can do is get what would I call this? All but center bit. Whatever. We can think of a better name later, right? So I mean, and then from here, you would do an and, right? So does that make sense why I did that? I don't know how does. Give me a second.
Will and work because I mean, will this I work because that could be anything from 0 to over 500. So.
Right. Yeah. So the and will work because again, this is 9 bits, right? So it'll always be less than this. So the first one will just basically it'll return 1. What this is doing, if you and it with I, it's only going to return an integer where all the bits are active in both of the integers, right? So basically this is what I was talking about earlier, is where you only grab the left and the right bits of the center and leaves the center bit untouched. Sorry, brain fart for a second. Does that make sense?
Yeah.
Okay. So then, if we have all but the center bit, we have to convert it to a binary string and then just count the ones, and then that will get us what the next state was going to be, depending on what it is for those rules. So I think you can do binary. Creating a binary string is just bin, right? So like what we would so. There's got to be a better name for that. Right? That should give us the number of bits active in any given number except for that 5th bit, right? Yeah. So then basically what we want to do is LE5. Okay, what part, which part, Derek? Are you talking about the bitwise and, or? Okay, so while we wait for him, I always forget that there's like a decent amount of lag between the chat and the video. So yeah, okay. Basically, what we're doing here is we want to check every possible combination of 9 bits to determine. Well, okay. Let's start kind of from the beginning. So on a Conway's Game of Life board, what's going on is each cell has a specific set of rules, right? We went over that a little bit. I don't remember if you're here, you know what it is, but basically, depending on the number of neighbors, the cell either stays alive, dies, or is born, right? And so what you can do with that, since there's only 2 states, it's binary, so you can actually check every single neighbor from the center, and you can think of those as just bits in a number. So you know how like decimal can be represented as binary, and I know you do because we did the computer science overview stuff that nobody ever graded. And so what happens is, now that you have this 9-bit number, you can just count the bits that are on and tell whether it's going the center cell is going to stay alive, die, or be born, right? And so I went through functions: stays alive, will die, is born, sort of. But instead of doing that, what we're doing is we're checking every possible combination of a 9-digit number, which is going to be 2 to the power of 9, right? So 512 numbers. And we're just going to check the bit pattern of each of those numbers and determine whether the the cell should stay alive or die based on the bit pattern we see. Does that make sense?
And then, so once we build this state map, we're going to use it in our get generation function, and we'll already have the answer to everything we pass in, basically. Like, if something should stay alive, because this, like he said, there's 512 different possibilities, and we can pass in. Yeah, I lost myself, but anyways, we can pass in each set of 9, I guess, squares. We'll pass that in, and we'll already have the state map, so we'll already know the answer of whether that cell should die or stay alive, because we've already built this map.
Right. Yeah. What'll happen? So kind of like what Derek says is just like this. He's talking about those functions returning a Boolean. The state map is going to take an integer between 0 and 512, and it's going to store a Boolean, whether the cell should be alive or dead on the next generation.
Yeah.
Yeah, sort of, Derek, except we're generating all possible states that could cause a cell to stay alive or die in the next generation, or be born, obviously. So, yeah. All right, so we have the active bit count, and then I always forget the exact rules. Let me go over here. So, any cell. Okay, so if bit count is less than 2, right? Then it's going to die. So no matter what happens, if the neighbor count is less than 2, then we're going to just say that it's going to return false in the next generation. So we just do this equals false, right?
Yeah.
Basically, we're pre-computing all of the things that we'd be checking if we just traverse through the graph is what we're doing. If any live cell with more than 3 live neighbors dies, or it dies if it has more than 3 neighbors. So greater than 3. Right, and then any live cell with 2 or 3 live neighbors. Okay, so
you can just put else.
Yeah, so oh yeah, we'll have to put else, but we need we need
elif in Python.
You're right. Thank you.
But the last one you don't need. You just need else, or will you return?
Yeah, I just need. Say what? Right, and then the next one is just going to be else, and then we're going to, if I remember right, that's also going to return true, right? So less than 2 dies, more than 3 dies. Any dead cell with exactly 3 becomes live. And here we're saying true. We don't actually care if it's alive or not alive, because any cells with 2 or 3 neighbors stays alive, and if it has 3 neighbors, it comes alive. Oh, do we actually have to check here? I think we do need an if statement inside here, because this right here will say if it's 2, right? So if it's 2, if it's 2, then it comes alive. But that's not always the case. It only comes alive if the center cell was on.
If the well, anyways,
you see what I'm saying? So
it doesn't matter, because if it's on already, then we'll just put it on again, and that'll be the same. We aren't changing the state at all. But if it's off, we're changing it to on.
Right here is the issue. And this is literally only going to activate if the active bit count is 2. But what we can do, I think, actually, is do I'm pretty sure you can write numbers like binary numbers like this in Python. Hopefully you can. Right? So 4, 1, and then 4. Because this should only be true if this cell is active, otherwise it should be false, right?
So you turn
then
it off, but if it's 2 or 3, if you're surrounded by 2 or 3 neighbors, then you stay alive.
Right. So here let me kind of run this through this if else thing.
Why you're doing the extra condition.
So this right here is pretty obvious. This one's a little less obvious, but if you look at number 4, it says any dead cell with exactly 3 live neighbors becomes a live cell, right?
Okay.
And then it says any live cell with 2 or 3 live neighbors stays alive. So no matter what, if a cell has 3 neighbors, it's going to be alive.
Oh, so
right?
If it has 2 neighbors, then it might not be. Yeah, I get it.
If
there is a difference between 2 and 3.
Yep, 2 neighbors. It just stays at whatever current state it's at.
Okay.
And so this should literally be all we need to generate every possible state and its corresponding aliveness value, I guess.
Okay.
Let's see. And we should probably check that. So we're going to build it, and then we just have access to the cell state map dictionary. So let's see. If we give it... How do we want to... So we could just do this, I think, right? Call it, and then after we call it, we can do cell state map. And then just so that, like, we know if there's 3, it'll turn on. So then 1, and then 1, 2, 3, 4.
Okay.
So that should be 9. Just double check, and then hopefully we gotta print it. But this should be true.
Okay, let's test it out.
Yep, that's true. And then if we...
Did you test it in the terminal?
Yeah. Oh, is there not a shared terminal right now? I think there... Oh, no, I didn't. Here.
There is a shared
That's
one.
weird.
Let me test it. Let me do Python.
Okay.
Seagull, just so it shows up on the screen. .py.
Yeah, I'm not sure why it tested in my other terminal, but yeah, okay. So it does work for that value, and then it's greater than 3 kills it, so this should be false.
That's part of Python's awesomeness, that you have to type, 4 less characters for elif statements.
Yeah, it's weird at first, but you get used to it.
Okay, where were we? So the state map is working.
Yeah. So now all we have to do is generate the integer as we go through the cells to determine if it's alive or dead. So I think that's going to be the easy part. Okay. So we don't need any of this anymore, and I can close my terminal for now. All right. So now we need to actually loop through the array we're given and generate the next board, so to speak. I want to just try one generation at first and see if we can figure that out, and then we can go and loop through the generations.
Okay.
Yeah,
that's good.
So then let's just say, because we're gonna need.
Wait. You're doing JavaScript again.
Thank you. I like as soon as I was like, yep, all right. Still doing JavaScript.
Yeah.
Give me a second. I have to reset. Jesus. Okay, so we're gonna look at the cell, and then do we care about its index? We'll come back if we do, I guess, right?
Yeah, I don't know if we do. So
Oh wait, we do,
we
because we
don't.
have to get the neighbors, right?
Oh yeah. So
Is it index before the element
that's
with
why I'm
enumerate?
so this we're building these bits. So this is because of these nested loops. This is why I'm thinking it would be easier if we built just every row into bits.
Um,
Because we
but
are
then we
what?
well, okay. So say what you're gonna say, because
Because so when this 2D list that's passed in, we already know it tells us what things are off and what things are on. So then we could build bit lists, but I don't know how long they'll be. Um,
well, so part of the problem is if you look at the tests and then you look at the last one,
okay.
the given like initial state of the universe is smaller than the actual expected answer, right?
Okay.
So if we convert each of these rows to binary, since we already have ones and zeros in them, how do we? It feels like it would be harder to expand into new rows and cells. Although, are you just saying instead of like making it a one-dimensional um, or sorry, not one dimensional, but instead of concatenating the whole thing into basically a string of one and zeros, just make each row um, like whatever the binary representation of the number is, or like
Um,
like
yeah, kind of like that. Or I mean, we could make it into string or bytes or whatever you want, but the I'm just thinking because then we have looping through nested lists. I just feel like this is gonna get messy. But keep going where you're going because you might, have a better way than I'm thinking.
okay. So with the numerate, I can't remember. I think is it the index and then the element? Is that how that works?
Yeah,
Like
yeah.
okay.
And
Um,
is the initial input an entire state map or just the chords of where I think it's the entire state map. That's my understanding. All
uh,
of the cells that are on and off. That would be really
who's
difficult
asking?
because I don't think they could. Because then we wouldn't know the size of the arrays, right? Because if they only showed the ones that were on. Um. Oh yeah, that's right. It could be like tuple coordinates or something. But they don't say anything about that in the challenge, do they, JT?
No, they're just gonna give you like currently what cells are alive and then generation numbers, right? So if you look in the test, it'll show you like input board state, and all of the tests should be that's what the input that we're given plus the generation
Okay,
count,
yeah, so
or
it is the full
yeah,
state then. Yeah,
yeah,
full state,
because technically the world our universe
the
is
whole world.
infinite, and we're gonna have to expand it and such. So especially since the first I think like three tests are the glider pattern, which for anyone who's not familiar with Conway's game of life, is a pattern that as like each state where it determines which next cells are going to be on and off will like glide across the screen. It's pretty cool. And technically, it'll never ever stop if the universe is in fact infinite. So.
Okay.
So then what we want here is we want to grab whatever cell is actually sorry we don't want to try to loop twice through the rows of the universe for some reason. Okay. So we have whatever cell we're looking at. We have the index, or we have the coordinates of the cell. All of us are having similar issues, except for the ones who aren't too lazy to exercise at home. All right.
Yeah. All right. I don't want to get too distracted because.
Yeah, I'm just trying to think of the best way to, because again we want to grab the neighbors, and we could just write like 9 if statements here, but there's got to be a better way.
Well, we're gonna slice it, right? If we're leaving it in list form, we're gonna slice the row that we want, the 3 elements. We're gonna slice the row above and then the row below.
We just have to check to see if of taking any of the 3 elements is going to be outside of the array we're given, right?
Yeah, we'll have to check that.
And so because we're only gonna look the row up above, below, and then the columns to the left and the right, and that's all we need to know. So then,
But so 1 second. We'll know. Wait. We can just check to see if the index is 0, so if on the x or y axis, or if we're at the end of the length on the x or y axis, right?
Right. Yeah, so we just need to check if, we're checking the index, right? Yeah, okay.
Game of life module called Ember. Never heard of that.
Huh. I do want to look into that. I think the game of life is pretty fascinating. So if the y is 0, it should be less than. No. We just need to check 0. You're right. And then, y is less than. Would be length of the row, right? Like, okay, so this one, we'll just pass right now. I'm just trying to get like an idea here. So if y is 0, or
yeah, and then
y
length of row minus 1, right?
Well, okay. Because we're going to be checking, yeah. So y is greater than, yeah. Okay.
Well, y will never be greater than the length of the row. Or y will be equal to the length of the row minus 1.
Oh, yeah, you're right, because 0 base index is a thing.
Yeah. Okay. Cool. And then you'll just do the same thing for x.
Right.
Yes, NumPy is awesome. But we're going to try to do it in just plain Python here.
So this should be length of cells, right? And then this should be length of row minus 1. Right, because
well then, well, because we're checking y here. Which. Okay, yeah, I think that's right. Length of row, yeah. All right. You're right.
Okay, so we should be keeping track. We should probably be keeping track of either a string and an array to build this integer, right? So, because I think what we want to do is keep an array to keep track of it, and then we want to sorry, brain stopped working for a second. We want to join it to a string and then convert that from a binary string to an integer, right? Or actually, no. Okay, so we can actually just build this using arithmetic as well, because we just look at the top left number, and then we shift. Then we set it based on that and shift one to the left, and then we check the second number and then shift one to the left, and then right.
Yeah.
Does that make sense? Okay, and basically we'll just we grab the number or it to the current position, then shift one to the left.
Okay.
So, we should probably, instead of continue is a thing. Okay, cool. Just making sure, right? Because we don't want to do, like, we want, if these are true, we want to kind of skip everything underneath, right?
No, because, so let's say if an edge, if one of these at the edge is true, then we need to check the ones around it still.
Oh yeah, that's true.
We need to check every cell, and there's also these corner pieces.
The corner pieces are going to be fun. Actually, okay. So basically, if we might need separate if conditions for each of these. So what we can do?
Yeah, we just need to get it done, and then we can optimize after.
Well, I'm not trying to optimize. I'm trying to figure out. So part of the problem here.
No, Derek is saying to do ON again. He always challenges us to do ON.
I think the way this happens is technically ON, right? And we only went through. We built the thing, and then we're just gonna loop through the grid once per generation.
Well, this is ON.
So. Well, it's kind of a weird thing to calculate because the grid is a 2D array, right?
Yeah.
So this would be the same. Doing it this way is the same as if we had taken each one of the arrays and appended it to a single array. So it's still ON, I think, technically.
Yeah. Okay.
So then what we need here. Okay, so how you have it highlighted, this is an interesting thing with live share. If I enter, it still has you highlighting the whole thing.
Oh.
Okay. So yeah, you're good. Okay, so.
But if if you're counting cells only, like if we're saying we're only actually going through each cell one time, so would not be technically be ON?
Yeah. Yeah. So it's definitely ON because the problem space is a 2D array. We're not going through. We're not hitting anything more than once, right? So n is like the number of elements that are part of the problem, and n squared is if you went through each of the n elements twice, or not twice, n times, right? So this is not n squared. Yeah.
Okay.
Computational complexity is kind of a weird thing. Okay, so if y equals 0, then what's happening is that the row above it doesn't exist. So that we're going to start by looking at the top left, the top middle, and then the top right, and then go left, middle, right, bottom left, bottom middle, bottom right. So the first thing that we can do here is It might actually, okay. So we could just shift the cell state left by 3, but it doesn't matter because cell state is already going to be 0 for this. So what we could actually do is if it's not equal to 0, then we can look at the cell above it and do what we need to do for the first 3. So, does that make sense?
Yeah.
All right, and the next thing we need to check, since we're going to check x, we need to check if y is not equal to 0 and x is not equal to 0. Because we're going to be looking at 1 to the left as well as 1 up. So this is going to be...
As we find these by the 3, should we be building a byte string or something? Something here?
I don't think we have to.
Okay.
Because yeah, we can just use the left shift bitwise operator after we add after we like grab a number from each one of the cells.
Okay.
Yeah, so cells. This basically what we're gonna do is bit in it'll be cells and then y minus 1, right? And then we're going to do y to y, or sorry, it'll be x to x plus.
Okay.
Or no, because we want to go 1 less than x, right? And then we're going to x plus 1. Does that make sense? I think that's right.
So, okay.
It's a little like convoluted, but so basically we're grabbing the row that's above the current one we're on, and then we're grabbing the values from that row is going to be 1 to the left of where we are all the way to 1 to the right of where we are. So that should be 3 numbers. And then we're going to cell state.
So we're just... yeah, this is where NumPy makes it easier.
I've never used NumPy, so I'm not sure like what about it would make it easier for this. If that makes sense.
I'm just looking at the syntax you wrote because it makes it much easier to work with matrices. You're doing it right. I'm just making a comment.
So we're going to or the bit that we're looking at to cell state, and then we just need to do cell states like that. We don't need to colon. All right. So for everything that's not on the edge, that should work.
Okay.
That's not on either edge, that should work. And then we're going to need one where the y is not 0, but x is 0, and then we're going to need one where x is 0 or x is not 0 and y is 0.
So we need to check for the corner states and the edge states.
Right.
Basically. Okay.
So
this could still be at the edge state though, because this could be at the end.
I don't think this could be at. I see what you're saying. You're right. Yeah. So, man, the conditions get interesting from here.
It's almost like we need to put this on a grease board or something first, but.
Let's see here.
Oh, let me get my cursor off. What are you doing?
This is sorry, I was replying to someone really quick about an appointment I made for okay, so how do we? All right, so we've got the y and x are not 0, but then we would, for this to work, we also have to check to make sure they're not the length of the row in the cell, right? Yeah. So, I mean, there's probably a better way to do this than what I'm doing right now, but or cell, not row. We did that earlier. -1 and x is not equal to length of row -1.
Okay. So this works for all the middle cells.
Right, and then all we need to do is check for the borders and the corners. But that's still that's like what, 8 if statements. So what's the best way to handle that? Oh, you know what we could do?
What?
Okay, so we can just check if the for each one of them. Never mind. We're basically doing what I was just thinking. I feel like I shouldn't be drawing this big of a blank. I've done something very similar to this before.
Okay. Well, do you want to go ahead and test out what we have here? Make sure it works.
Yeah, we could do that.
Well, I guess we're not.
The problem is we're not going through all of the arrays, and right now we have to build an array to return, and we're not doing that just yet.
Yeah. We'll just write a whole bunch more code and test it out.
Right. Okay.
Alright, so which state are we going to check next? We want to check.
We should probably let's kind of like check them. Let's do the top left first, right?
Okay.
So if and x is equal to 0, then what are we going to do there? We're only going to be looking at the if top and so basically this goes away and then these go away. So we're looking at the bottom right square, 2 by 2 square of the 3 by 3 array, right?
Okay.
So how do we? The best way to grab that, is there a better way than just manually doing it?
To grab
we do. I actually feel like we're not done here now that I'm looking at it. I want to double check, but this is only one row, right?
Yeah.
This is not actually checking all the rows. So,
oh, I thought you were going to add that in after.
Oh, yeah, you're right. We could do it. We can just check like, okay. So here we could just build.
Okay, well, if the bit is in here that we're checking, then because so if we get we just need to get the 9 by 9 or no 3 by 3 matrix, turn it into bits, and then check the cell state map with the bits. So
I feel like we could just write out like checking each individual cell, like from the top left to the bottom right, and then if it's out of bounds or doesn't exist, instead of writing like looping through rows of cells, we can just grab each individual cell. Does that make sense?
yeah.
That might be easier than figuring out like an efficient way to loop through everything. It's just write out like 9 statements that handle it for us.
Okay.
So like.
Oh, go ahead.
So we could do something like cell state equals to How do we, okay, so it'd be, is the first one rows, so it'd be like y minus 1, x minus 1. Now that'll give us out of bounds error if we try to access it, right? At 0, 0.
Do you want to add a try except?
Oh yeah, I guess that's, yeah, that we could, yeah.
It's like
all right.
Yeah.
Yep. We don't actually need to do anything if it doesn't exist. If we were to put a loop over this try and except, this is actually something I'm not sure exactly how it works in Python. Could we just put continue and accept and still keep going through the loop? Does that make sense?
Yeah, I don't see why not. Because we're
okay, I just didn't know. Yeah, so we could just, if we're just gonna like handle it by not doing anything, because if it's not there, it doesn't exist. We don't. The only thing that we might need to do is shift cell state by 1 to the left, and if it's empty, that won't do anything. But if it's not empty, it will. So we'll do that. And then here we do for we're gonna do another nested for loop here. I in range of 3, 0, because it'll be, well, no, so we want -1, 2. And we're only doing the 2 here because it is, this number is exclusive, I'm pretty sure, in range, so it'll go -1, 0, and then 1.
Okay.
And then 4j, right, and then here, we can do this, and then...
Now it is definitely not in.
No, it's, oh yeah, you're right. But this is a weird problem. I don't think you can easily do it in O of n because you have to check all the neighbors for every single cell.
Yeah. You're fine, don't worry.
But then we don't need this at all. So I think this should build whatever the next state for the entire board should be pretty easy to, oh no. We need to do this. There we go. All right. What were you gonna say?
Oh, I was just, I was wrongly thinking this would be out of bounds, but then I realized it's a range, so. Yeah.
Right.
You're right. Yeah.
That's, and yeah. Okay, so we're building that. We kind of need, we probably should just use a new array, right, to store things in, and then,
okay.
And then for each cell.
Yeah, go ahead.
Oh, actually, we'll start with just a regular array to make this a little easier, and then for every row, what we're gonna do is universe. Is it append in Python? Yeah. Right, and then here we're going to take whatever the y is, and we're going to push the cell, right? Because we're going to head down the row of the first. We're going to head down for each cell of the first row, and then second, and so on and so forth. So once we've got the state here, we need to look up what the state is. So next state equals cell state map. And then cell state, and that should give us whatever node we're currently on should be for the next generation. And then we just push that to the current universe row. Right. Next state. And I don't think this is gonna actually solve. the thing. There's still some steps we need to do, but that should give us something to work with.
Okay, so we're so cell state here. Okay, and then we're looking through the map here, matching it up. Okay.
So let's see what happens when we run the tests. We got 4 errors, so that's heartening. What are we doing here? Oh, we're getting a key error, which is interesting. So I wonder what the cell state looks like.
Oh, you ran it down here, I see.
Yeah.
So in the terminal it says ran 4 tests. Okay.
Yeah, so I'm gonna see.
So you're gonna print out the cell state on each loop.
Yep. For that though, I'm going to need to grab stuff from the test because I want to do it kind of outside of everything and just do this.
Where are you? Okay, so you made a test board here, and okay, all of this stuff is for testing.
Yeah, I just grabbed it from the test. I just want to do this in isolation, and we'll see. Interesting. So, oh, it gives us the key. I feel dumb now. So for some reason, cell state map is empty, and it's because we didn't build it. We just have it as a function. That's
Oh, right. Yeah, because our cell state, we have to build it first, so we have to call this function. Okay.
Yeah.
Build
All right, let's try that again.
Okay.
And actually, we can do, instead of just printing the outboard state, because it shouldn't change anything. But
oh, cool.
I don't think that's how that's supposed to look.
No, but we just basically every cell is alive, no matter what. That's our game of life.
Oh no, that's not what's happening. That's printing the cell state. That's what that is. So, but that's an issue, right? Because they shouldn't all be 1.
Yeah.
So why is it always 1? We need to derp. So we need to shift it to the left by 1 every time, regardless of whether it fails or not. The try except block fails.
Okay.
Oh
yeah, because
if it doesn't fail, then we're just. Yeah. All right. Well, it's still not. It's still not what I want.
No.
If we HTMLize the input board state, and then we'll do.
Okay, so you're printing out the initial state.
And then the output. And there's going to be nothing. There's no generation between this. So
wait, this might not be wrong though.
This one has. I mean, the first one should still be on, right? Because it has 2 neighbors.
Yeah.
Or no, it doesn't. Sorry. The middle one should still be on. Is what I'm saying. Because it.
Sorry, gray is on, right?
No, white is on. So if you look at did it not run the second one I did for you? Oh, it did. Okay.
So white. Wait. Oh. The lighter color. Let's say the lighter color, because they're both like shades of gray. So the lighter color is on, and the darker color is off. Dead.
For you, it looks like it's the opposite.
Oh, is it
the darker color for you is on? Yeah, I'm using dark mode. You're using light mode, which confuses the two.
Okay, that's confusing. Yeah. Okay, so these are dead. All of our people are dead.
Yeah, all of our people are dead, but it should not be.
Yeah. Okay. That's sad. How
I
do you
was
want?
really confident that was gonna work.
It's always nice when it just
Okay,
works right away.
right, and I think the state map's fine. Like I'm pretty sure we made sure that working. So it's something to do with this this row. So I mean, let me just go ahead and print the cell state now that I fixed that one portion, and we'll see like what's going on here, why it's still dead. So they're still returning 1 for some reason.
Wait, let me catch up. Oh, it didn't. Oh, I see, it is. Okay. If I scroll up, they're all returning 1.
Right.
Okay.
And that's not what we want. So,
So we should be debugging, yeah, inside the inner loops, right?
yeah, it's gonna be somewhere in the I or J loop for sure. Well, I guess the first thing we can do is just print I and J and see what happens there, right?
Okay. So you.
Yeah. So.
Okay, that's ING.
Oh, oh,
Ooh,
I feel so stupid now.
what?
So I and J is always going to be I and J is always going to be between -1 and 1. I'm not adding it to the X and Y values of the current. So like it's not being offset by where the current cell is. It's just looking in those specific cells.
Oh, yeah.
Um, so it'll be Y plus I.
Okay.
And I think that's where we're at with it. So let's try it again. And please nope, still all of it is dead. And let's see. I guess print the cell state again to see if.
So I don't know if. I'm trying to think about this. So
Right, because so I should be. The first iteration of this, it will be looking in whatever y is minus 1, right? It's not +1, but because it's going to be a negative plus -1 essentially.
Yeah.
So it'll look up 1, and then same for x plus j. It'll look left 1, and then it's going to look right 1, and then right another 1, and then it goes back to the middle layer, and then left 1, middle, right, and then bottom left, bottom middle, bottom right.
Okay, so this seems like it should work.
Right. Now that we're modifying it, I'm going to try. Let me clear this, and then I'm going to run this again, and it's still all 1, which is really interesting. Cell state, after these 2 loops, cell state should be modified, and so maybe instead of printing it afterwards.
Or you could print it after the try except, so you get it no matter what, right?
Oh, I see what you're saying, yeah.
Oh, good luck with Redux. Maybe after this you'll move to View. No, I'm just kidding. Redux is fine.
It's a little like weird to set up at first, but so we're not just getting 1s now, we're getting 0s and 1s.
That's good. Are we though?
Well,
we got 1 0. Oh no, we got more zeros. Okay.
Yeah, we've got a couple zeros, but cell state shouldn't be 0 or 1. Cell state should be a number between 0 and 512, so it shouldn't always be those, which means something here is not working the way that I would. Do you have to do this? I bet.
I don't know. Oh, wait.
Yes.
That's
that
better.
is exactly why. Okay.
But how come some
we
of them
got
are over 512?
Yeah, I don't know. This,
Have
so let's do.
Have we printed out the what is it called? The cell state map? We know
We
that it's
haven't.
512 and we didn't write a bug in there.
Nope. Okay, so we could do that. We could do, it'll be after we've already generated, so then we can do print. How do you get the keys of a dictionary?
Wait, where are you? Where are you? Oh, you're down there.
I'm at the bottom. Yeah.
Yeah, you use the square brackets. Oh, to get the keys of a dictionary.
Yeah, like a list of keys
Dot
to see
dot
how many keys
keys.
exist.
Use the keys method.
Oh, okay. So, okay. And then it's so weird to me that len is a function and dot keys is a method. But then, like, if you go to back to JavaScript, it's the opposite.
JavaScript is, yeah, the opposite of everything.
Okay, so I printed everything as a binary string. Oh, it's not gonna work because we're generating it, so it has to be. Give me 1 second. It actually has to be right here.
Wait,
And then I'll.
Where are you?
So I had to move that println to the top of the, like, right under build state map, because it was erroring out before it finishes the function, which means it was never going to print anything.
Oh, okay, you moved it up here. Okay, cool.
Yep. Yeah, 512 is the length of the keys.
Okay, cool.
So we're doing something wrong in the generation of the cell state is what's going on here. Higher order reducers. Okay.
Okay, so now we know that our state map is okay, so we're not doing something wrong there.
We're adding an extra 0, it looks like.
In the state map?
To the cell state. Because if we run it, the bottom binary thing it's looking at is a 10-digit number.
1, 2, 3,
Does it do it consistently?
6, 7, 8, 9. Yeah, it is. Okay.
So it does it consistently on the second cell, but not the first, it seems, which is interesting. So let me change the first cell to a 0 and see what happens here.
Okay.
Same issue. That's interesting.
Okay, so you reran it. And
yeah.
Yeah, why is it getting longer there? Okay, you're getting a key error because it's too long. So let's see. So okay, that's the print.
I'm gonna try something. I'm just gonna try to shift it right down, so it'll shift right, which will get rid of that last bit.
Okay.
Right. Oh wait, that's interesting. If you look at the number.
What number?
In the terminal, the last two binary strings. This one? Or
these two?
I don't know how to.
The very last one that printed before the traceback?
Yeah, the last two there.
Okay.
If you look, the last digit 0 turns into a 1, and then it adds a 0 as well, which is interesting. So what's going on is it adds a 1, and then it shifts to the left, and then it's adding another number and shifting to the left again. But I don't know why it's doing that, given that like just the math of I and J should only ever put 9 digits in there.
Yeah.
Right? Except for I want to say it's gonna shift no matter what.
Maybe we should.
Go ahead. Well, so if you look at the top of the output from the last time we ran it, it starts with 0, and the string is 0b0, right? But if you look at the start of the second cell, it's 0b10, which is interesting. So it's always one length. The second cell, for some reason, always starts one length greater than the previous one, it seems, before it crashes. I don't know if the pattern holds.
Yeah, I don't know why it does that.
Cell state, it starts 0, then we try it.
0b0 and then 0b10.
And it should, the second one should actually should only be 11110. I think. Or sorry, no, it should be 3 zeros. 3 more zeros. So it should only be 3. Because if you look, like the binary string should just be for the second cell, because the row above it doesn't exist, so that should all be 0. And then the one to the left and one to the right of it is 0, and then bottom left is 0, and then the only ones that are active are the bottom middle and bottom right.
Yeah.
So it shouldn't. I'm not sure where this 1100001110 is coming from.
Maybe
What do
we just need to step through every single action that is taking.
Okay.
Every single step.
That's not a bad idea. Yeah.
I don't know if you want to do that with print, or because this is a shared.
Yeah, I'm not sure the terminal, or sorry, the debugger is going to work with that.
Yeah. I don't want to try it here and crash this. Because this share seems a little bit finicky.
All right, so what we're doing here is just that way we know what's going on. And that should be all we need until the end, and then after the loop finishes, let's go ahead and print. And then we will clear, and let's see if we have any more. We don't need those. I just want to make sure.
I don't see what you're doing. Okay, you're commenting those out.
Yeah, I just want to make sure there was no other print, so we knew exactly what was going on.
Okay, so we call get generation, and it will print from within inside our loops in the function. All right.
Yeah.
Go ahead.
Okay. Oh, it's gonna print them as integers, not binary, which might we should probably print them as binary.
Yeah.
We don't actually care about the integer version of it, except that it's a key.
Okay.
All right. Did it run on your side?
Yeah.
Okay. Just make sure I was in the right
it ran
instance.
And it didn't give us a traceback.
Oh, that's what? What is going on? What?
I don't know. Why didn't it give us a traceback? So it must have been giving us that error from the HTMLize function. I don't even know. But that
okay.
function wasn't erroring before.
Let me try it again.
Okay.
Input board state. Oh, I was like, that looks completely different. And it's because it was. So, yeah, so it works now? It's like sort of. We're not getting the I don't think we're getting the expected output, but I I don't know what just happened.
That's weird. That was just weird what happened. Okay.
I feel like that's not all that uncommon either.
Maybe it was something with live share. It was caching something and didn't run the latest version. Or we didn't save it before. Maybe we didn't save something.
That could be it.
We can rewind this live stream later and figure it out. Anyway.
So that's definitely not the output that's expected. Is kind of the problem. Let's see. So, for instance, this top right one would need 3 neighbors to come alive, and it only has 2, right? So that's not working as expected.
Okay. I'm confused about alive and dead now because of the colors. I'm using the light theme, so I don't know.
The dead one is the L, or no, all the alive ones, sorry, are the on the bottom one, it makes an L at the right side.
Okay,
or
so
right
all
bottom.
The dark ones are alive.
Yeah, for you it's the dark ones. For me it's the light ones.
Okay, the dark ones are alive. Okay, then this one guy died. In the top left one was alive at first, and now he died.
Right, and that's expected.
Yeah.
I believe because he only has 1 neighbor. The middle one stayed dead, which it shouldn't have because it has 3 neighbors.
Which one are you talking about? Which?
The middle top cell.
Okay.
From the it should have been turned on because it has 3 neighbors, right?
Oh yeah. Oh.
Mm.
Oh, never mind. I thought I thought of something good.
So that makes me wonder if like what's going on. Each of these are correct now, like as far as being between 0 and 512. But it looks like, I wonder if we mapped it differently than we created the integer here, is the only thing I could think of.
Okay.
It shouldn't be though, because we grab. All right, let's go back to figuring out what the key is real quick.
Wait, where are you? Where are you? I have to scroll up with you.
I'm in the.
Okay, I found you.
Oh, right. Yeah, sorry. I forget how like streaming and like we're also showing this to other people. I honestly completely forgot we were streaming this for a second. All right, so yeah, let's see here. Let's play this. And each one of these are the grid. So actually something that might be helpful here is instead of printing the cell state by itself, is we could do something like, oh wait, I think I could just print tuples in Python. Right, I think that should work. Or actually, we'll do x, y because that's how we think of it, but not how you access it necessarily. So I just want to check. Let's go to 0, 1, 1. I should have known that. And we want to check what this looks like. So it should literally just be 100, 0, 1, 1, 1, 1, 0. 100, except that is 1,000.
Wait,
so we're adding an extra.
Which one are you looking at?
1, 1 in the terminal. You can scroll down in the terminal, or did it not print? It might not have printed everything. Or sorry, scroll up. Terminal.
Yeah, I see 1, 1. And why are you looking at that? At that one?
Because how I have this working is if you take this input border right here and you just basically get rid of the rows and make it one string, right? That's a byte representation of an integer. It should be the same as this string right here, right?
Wait, I don't see what you're trying to...
The 1 1, my bad, it doesn't highlight in terminal. So if you look at the 1 1 in terminal, that should be the same thing as if you just laid this out side by side. The bit should be the same.
Oh, okay.
Right? Because it's, yeah. And it's not. It's got an. It's got two extras.
1 1 is this middle index in the matrix.
Yeah.
Okay.
Mm-hmm.
So, and then this, you're saying that these bits should line up with the whole, what am I talking about? Matrix.
Right, yeah.
3, second 3, and then this bottom row here. Okay.
Right, and we're actually getting, again, so we're getting 2 extra zeros. The first 0 comes just before the block of 4 ones, and the second one is at the end of the string.
Okay, so these are turning into the wrong bits. They should be ones, but they're zeros.
Yeah, we actually have 10 here, which means, so it should be 1 0 0, then it should be 1 1 1 1 0.
Yeah, why do we have 10 again? And it's not throwing an error either.
Well, let's see what this number is in decimal. I just hit Control-C instead of Control-Shift-C.
Okay. Where are you typing? Is it somewhere I should be scrolling to or somewhere else?
No, I just went to Google to convert the binary to decimal. So yeah, that's weird. That's 572 in decimal, which means it should definitely have given us an error. So now we went from it giving us an error and we don't know why to it not giving us an error and we don't know why.
Yeah, because it should be the key error again, right? Because it's not contained in our lookup table that we made for the state map.
Yeah. Okay, so we're gonna print one more thing.
Okay.
Map. This is in that giant print statement that I've already got.
Wait. Let me zoom out.
Oh, that's right. The reason it doesn't, I forgot. I put this line in here. Do you see where I'm highlighting? It's the next state equals self state map. So when we were having the issue with the 10, I was curious, and maybe we were just accidentally shifting it left by 1. And so I had started de-shifting it by 1, which is why it fit into the, without giving us an error, it fit into the thing.
Oh, okay.
Because I was already pre-taking care of that. But there, if you look, there's some times where it's like, okay, that's not going to work. Like 2 2 1, and the output, like binary strings, wouldn't work in the terminal.
2 1. Okay, 2 1 1 1 0 1 0 0 0. Yeah.
Because there's a 1 left of the, so that's not a good solution. I just wanted to see, and that at least that makes it work. Well, sort of work. It's not really working. Okay, so we are putting an extra 0 in. So if we get rid of that extra D shift and we run it again, then we immediately get the same issue that we had a second ago. So why is it giving us this issue? So what I'm going to try to do is under self state under the first 2 for loops, I'm just going to have a count, and I'm going to see if maybe there's something. I'm just going to put count plus equal to 1 during the nested for loops, and then afterwards I'm just going to print the count and double check that I understand what's going on here.
Okay.
All right, nope. So it is 9.
Wait.
Okay. So it's in the terminal.
It's printing 9 twice and then throwing a trace back, and that's for each row
and it's
that's looping through. That's printing 9 and then 9 and then throwing a trace back, right?
Yeah, well, so it's printing through, it's through each cell that it's looping through. Like
Oh,
each one of these are individual cells, yeah.
okay.
So it is reaching, it's going through all of this, and then the first time, and it works because it finds an answer, which is the correct answer. It should die. Um, and the second time it loops through, for some reason, cell count has an extra something somewhere on it. So, all right, now that we know that, I don't know, I just don't know exactly what's wrong, or else we wouldn't be here. All right, so
Okay.
let's at the beginning, let's print, we'll print the cell state at the very beginning, and then, how do we want to, let's just see what happens. Oh, binary, forgot binary.
Bin.
It's been, yeah. That's not even a JavaScript thing. I don't know what I was doing.
You were saying binary, so you typed.
All right,
It's
and then
hard
we'll
to
put.
type something different from what you're saying. Okay, so.
I don't think that was the correct place to separate it. Actually, it should be. I'm sorry, because that's still generating it. So you want to. You'd also do it after, but. Okay, so if we go to the bottom, yeah, there we go. So the first two iterations, 0, 0, which makes sense in this one. There should be one more, though. Right? Because...
Well, the third iteration is throwing the trace back, or
Let me check.
Because
oh, no, the second one. Sorry. If you look at the very top number generated, the top binary key generated, it says 0 and 0, which is what you would expect for the first two. But you also expect a 0 from the third one, because that should be a row that doesn't exist, right? So there should all be zeros. And then...
Here?
At the top of the, sorry, at the top of the terminal output.
Yeah. So instead of, so the first two we get zeros, and then the third one we get 1, 0.
Which doesn't make sense to me.
Because when we're checking when the row is at the 0 index, then there's nothing above it, basically. So we should get
so
all
if you
zeros
look
back.
If you look at the input board state, like in the code, then yeah, effectively what we'd be looking at is that comma, or that commented out row above that, though 1, 0, 0.
There is no index at -1 from the first row. Yeah, so it should be all zeros. I don't know what's happening.
If we take this, that's not what I wanted to do. Copy it, and then...
Wait, where are you?
I haven't... I'm up at the top of Git generations. I haven't done anything just yet. I'm just copying that above there, so I can like look at it while I'm you know what I mean? Like kind of go through the loop and look at this. Okay. So, actually, that shouldn't be... because this should be...
We've been doing this for 1 hour and 45 minutes.
Oh, Jesus, yeah. I could do this all night, honestly. I get really sucked into these problems. And I guess we don't need this extra comment. So, all right, so what we do is I is going to be -1. So we look at, I mean, in this case, -1 would be looking up here. And then J is also -1, so it should be looking here. Which is kind of weird because we're in the input board state now, apparently. But should be looking here. So cell state should y plus I. I guess what we could do is every iteration we could do y plus I and then x plus j, and just see what that gives us here.
Oh, plus, that's a capital J.
Did I? Yes, it is.
Wait, let me see.
All right.
Okay, so
I'm gonna actually print one more time to try to make it more legible. I separated it by like things. So we've got -1, -1.
okay, so for the first row, yeah, it's looking up a row. So -1, -1, -1, 0, -1, 1. And those all go through except because they don't exist. So they go to
right.
except.
So right, which is just shifting it by 1, which at this point should do literally nothing, right?
Yeah.
And then the next one we get is in the top row, and it's looking.
Visualize this. So I mean, so everyone on the chat can see.
Right.
Okay.
Then we look at the middle row, or the top row, and then the middle row. And each one we looking at cells -1, 0, 1, -1, 0, 1. And so let me count.
Wait,
actually, 1, 2.
So in the terminal. Oh, you haven't run this yet. Okay.
Yeah. I'm trying to think. There's probably something. I want to put another print statement here. Let's do something like this, and then we'll see results. Or actually, we'll just say cell.
Can you make those different lines? Yeah.
Okay. Yeah.
Or different statements or something.
Yeah, it was getting a little bit long. Will this work for the first print statement? Is that off the screen, or is that fine?
No, that's good. That's good. Oh, I think.
All right.
So. No, they're
good. So we've got cell state, and then I want to do one more print statement just to separate each iteration as we go through this. And so I'll clear the terminal, and then I'll run it again, and we're going to see a lot of information. So.
Okay. So do you want to start at
-1? Yeah.
Let me scroll up. I don't know why it's giving me all this white space at the top of the terminal. Can you expand your terminal a little bit? Like drag it up? You know what I mean?
Yeah. Yeah, I did that. Did that do anything for you?
I don't think so. Oh well.
Okay. Yeah, I keep mine pretty compact so I can see more code.
Okay.
So cells -1, -1, 0 for some reason is giving 1 as the answer.
I don't know.
Am I should I be accessing with XY? Because Y is the row, which is the first thing we're grabbing, and then X is the cell, which is the second thing we're grabbing. So I don't think that's... Yeah, that's so... Okay.
So we need to switch this, right? Shouldn't it be X first?
Yeah, yep. Yeah, let's try that. That's probably what it is.
And then, but X is... Okay, so yeah, it doesn't matter there. Okay. Keep going.
Okay, so this isn't correct, but I want to see. I just want to run this and see what happens here. Okay. Actually, might as well just change it. Nope, we're still... I didn't change it in the print, but I changed it in the actual thing. But we're still getting 0, then -1, 0 is 1. But anything with a negative in it should not exist.
Yeah. So...
What's interesting is cell state is still 0. And then... okay, here we go. So it's 0 here. And then the cell's 1 here for the second one, and then okay.
Oh wait, I'm in the place. Okay. Yeah, why is this coming back as 1? How can we debug that? Is that...
I mean, let's try something here, because the other thing I could think of is it's not actually getting passed in how we assume it is, but that doesn't make any sense. So here we'll just do XY. And then we're still getting a 1, and it doesn't make any sense.
Okay, so we have -1, -1, which is checking off screen or outside.
Now I'm curious, actually. What if we do, instead of doing this, right? What if we put this in the except block and see what that prints out? See what we're catching and what we're not.
Okay. Alright, so we're only catching 3 before the traceback. So,
yeah, so why are we getting 2, 0, 3 times? Oh, that's X and Y. That's right. So that's fine.
Oh, right, because...
yeah, this is going to... But that's weird, so this is only capturing it the second time.
Yeah, how come we're not getting it the first time?
Well, alright, we could do the nuclear option. Just delete it and start writing the for loops again.
No! We're 2 hours in deleting it all.
But this isn't a lot, right?
Why don't we comment it out?
Yeah, okay, we can do that. It's a little less drastic.
Yeah.
I feel like here I need to do a little extra step, because if not, I'm just gonna look at this while I'm writing it again. So we'll just put it way down here where I can't see it at the bottom. And,
Okay.
so, oh no, I'm typing down there.
All right, so we're still looping through the rows and each cell.
Yeah. I think this is correct.
Jared, I left for 2 hours. Yes, we've gotten pretty close, but we have some bugs that we're trying to fix. And
Yeah.
we have a particular bug that we can't figure out what's wrong with it.
All right, so this is printing the range that I thought it should, so that's completely okay. And then
okay, 1 second. I'm gonna. Okay, keep going. I'm just gonna paste the challenge into the chat again, in case anyone didn't see it. That's the challenge that we're working on. And you can actually train in other languages, so you don't have to use Python.
Yeah, and then we just try.
Okay, so npm run fixes all bugs. I'll keep that in mind.
Who said that?
Jared.
Oh, okay. Well, Jared does know everything, so npm. What was it now?
All right, so.
Yeah, so we need the initial cell state still. I feel like this is still going to end up exactly the same thing as what I wrote.
So.
Yeah. But it might work, because remember last time it just randomly started working. So basically we're just going to grab this and we're going to OR it against whatever cell we're looking at, and we're going to be looking at the cell based on. Are we sure it's XY? I don't know why in my head I was thinking it was YX instead.
Yeah, I don't know why we didn't catch that. I think we were just staring at it for too long. Yeah.
Yeah.
That's good.
Yeah, okay. And then we need to adjust it depending on whatever. And I and J doesn't matter where we're adding it to either of these variables, since they are both exactly like they go through the same. Oh wait, it does matter actually, right?
Oh, no. It would matter because it would, like, we would be going through it vertically versus horizontally, one way or the
other. Oh yeah, that's true. So let's maybe. Well, that still is that. There's no way that was our error, because that wasn't the issue. And then 1, and then if nothing happens, we just shift it once. And then from there we just
we import NumPy. No, I'm just kidding.
I mean, if you can think of a way to solve it with NumPy, let's do it. I'm cool with it. And I feel like that should work, right? Because we're checking each of the adjacent cells, or the neighbors, and then we're just ORing it to the ones place, because it's only going to be 1 or 0, and every time we OR it, we shift the number to the 1. To the right once. And then if we try to grab something
not a Pokemon, but that is a good name for a Pokemon.
Give them a little bit. They're exhausting names. They'll come around to it. Okay. So let's run it and get the exact same error.
That's very positive.
Wait.
Okay, so we're printing. Okay, so we're printing.
Int object is not scriptable.
Initial. Did you run it already?
Yeah.
During handling of the exception, another exception occurred. Oh, int object is not subscriptable.
Oh, why did I put cell state equal? Okay, hold on. Let's try that again. Same thing though. Where's the int? What did I do wrong this time?
Line
Oh, it should be
40.
cells.
Yeah.
Yeah, I shouldn't pluralize it.
Okay.
Hey, it wasn't the same answer or same error though. That's a good thing, right?
Local variable cell status. Why are cell status? Oh, you know you're not defining cell status anymore. You're defining cell
Where
state
am I?
here, but you used to define cell status here. Yeah.
Look, I'm running on 7 hours of sleep in the past 2 days. Okay, so we are getting back the same issue where it's somehow getting a number that's greater than 512, and which means it's shifting one more time than it should.
Okay, so we're getting this
Um,
key error, the same thing, because in our lookup table that we built, it's out of bounds. All right, so what do you think? We're at 2 hours now. We've been working on this for 2 hours. You think we should take a break, come back to it? What do you want to do, JT?
yeah, I'm cool with taking a break, cause like, or at least in my experience, that's when I solve the problem. Is as soon as I like put it down and go start playing video games, it comes to me.
Oh,
So,
video games.
uh,
I was thinking like take a
which
walk and eat dinner, but video games are good too.
oh man, video games are what I live for right now. So can't do anything else. Well, actually, I've been programming I've been learning 3JS, and I made a Rubik's cube in it, which is cool. But
Nice. You'll have to show us sometime.
yeah, for sure. Um, we could also just look at my C# thing, which apparently I have built a Conway's Game of Life in C# before.
Oh,
But it feels like cheating a little bit.
yeah, I did Conway's Game of Life like 5 years ago, but I really have no idea what I did. I can't
Yeah,
remember how
yeah.
long ago it was or what I did or anything. Yeah. All right,
I
so
have notes in here, but they're terrible.
you have notes in here?
In no, in the C# repo with the
Oh,
Conway's
okay.
Game of Life, but they're garbage comments. So I still don't know what's going on in here.
Yeah, code you wrote 6 months ago. All right, so why don't we post this code in a gist and then call it quits for now and come back and work on it again? That way other people can see what we wrote and maybe they have feedback for us. What do you think about that?
That's fine.
Are you
Yeah,
gonna
that
post
works.
it?
Yeah. hmm
Okay, cool. And then we'll
Uh,
post the link in the chat here.
what's the okay? Let's grab the name of the kata. And so when did you want to come back next week, or like what were you thinking as far as that's concerned?
I don't know. What do you think, everyone? Should we finish this during the week or should we wait a whole week? I really don't want to wait a whole week to finish this. But
I don't either, if I'm being honest, but like I don't know what your schedule looks like. Mine at the moment is open, but that can change really quickly as I'm sitting on apps and get like interviews and stuff.
yeah.
Uh,
Yeah, we'll plan a time. Hopefully it won't be before the week's up. I don't know, maybe we'll stream, you know, Tuesday, Wednesday, sometime then. We'll pick a time. We'll finish this.
I put the gist in the chat, although I don't know how it works or if you have to approve the.
Yeah, I think it won't do links, so why don't you send it to me on Skype real quick? And
Okay.
I'll change back to the screen, yeah. Okay. Now I'm off camera secretly checking Skype. And copy link. Now I can post the link in the chat.
Oh, I even got the like commented out code that I put all the way at the bottom. I forgot about it.
Okay, that's cool. Yeah. It's the stuff behind the curtain. People understand. Okay, so we have the gist. Yeah, we're gonna come back and finish this week. Let us know if you have any. Oh wait, it's just my face on here now. 1 second. There we go. Yeah, let us know if you have any ideas, recommendations, something we could do better. I'm sure there's like so many different ways to solve this problem. So even if you solve it in another language, or you have an idea about how you could do it in another language, maybe that'll give us some, a spark for how we could debug it here.
Right.
Yes. So we'll post a live stream. James and I will work out when we can do it this week. Do you have anything else to say, JT?
Um, Not really. No. Nope. I'm good.
Yeah. Besides, if you know anyone hiring, JT is currently looking for a job. He's an
Yeah, that
experienced.
I meant to say that.
Yeah. um, yeah. Other than that, we'll see you next time. Thanks for all your help in the chat and for being just as lost as us for the last hour.
2 hours, right?
Well, we were getting somewhere the first hour, and the second hour we lost.
Yeah,
We were
hit a giant roadblock.
Yeah, basically. So we need some sleep, some food, and then come back to this. All right. Thanks everyone. Thanks James. Have a good
Yeah, have a
night.
good night, guys.